Hello and welcome to Azure Databricks using open source libraries. I'm drinking out of our mug today in honor of this presentation. And my name is Brian Kafke. I'm a data solutions enabler at Microsoft. And I need to talk about what are libraries. So I kind of use a library books metaphor there, but the idea is reusable code functions which can be provided to the languages supported by Spark, which are R, Python, Java, and Scala. And we're going to focus really on R and Python at this point. So to kind of get your head around what is Databricks in case you're not familiar with it, I do encourage you to go watch my other video, which is a brief introduction to Azure Databricks, and that will give you a nice overview of how it works, what it is. And I even have another one, which is a deep dive on Databricks SQL, so really good one to look at as well. But for those that just want to maybe a refresher. So at the center of Databricks is Spark. In fact, one of the founders of Databricks, the company, which is not part of Microsoft, by the way, wrote Spark and turned it over to the open source community under the Apache project. And so they maintain it from that point forward. In fact, Databricks, the people at Databricks do most of the maintenance, a good chunk of the maintenance for Spark itself, the open source version. But Databricks, the person who founded it, or the people who founded it, wanted to provide a really easy to use, self-contained, secure, collaborative environment for data scientists and researchers, etc. And so they developed Databricks as sort of a central portal, a wrapper, if you will, around Spark, which is really important because it's not easy to really use all the features of Spark, and even just installing, configuring, and running Spark can be a challenge. So Databricks really simplifies all that. And it makes it dynamically scalable, so you can set up your machine under the covers, what called clusters, so that they can dynamically scale to the workload, etc. So it's got a lot of great features. And what does Microsoft bring to the table? Well, interestingly, Databricks was written with cloud APIs, and so it was optimized to run on the cloud. They kind of knew, I think, when they built it, obviously, that that's where they were going to go, and they were looking for a home. Where would the best place be for Databricks to sort of settle down and call it home and say, we're going to really settle in and integrate with this environment? And it turned out they met with Microsoft, and similar sort of meeting of the minds and cultures. Microsoft is all about enablement, making things easy to use so that everybody can get access, so the democratizing, if you will, data and access. Because data is the new gold. Right now, I think it's pretty clear that the most important thing going on in the entire technology, if not all industries, is leveraging data. That's where it's at. And that's why my job is to help people do that. So Databricks is a key tool for that, but you need to be able to integrate it and use it well. And Microsoft is about enablement. Databricks was all about enablement. So by getting together and at a very low level, the technical engineers in both companies really worked together for a long time to make sure they could seamlessly integrate this and provide Databricks on Azure as a software as a service, meaning point and click, use it, and billing isn't separate, nothing separate. You really can't separate it out from Azure itself. And they had a great job. They did an awesome job of this. I'm really excited about it. And so what does Azure bring? Well, the goodness of Azure is you've got a lot of types of data resources and just resources in general. You've got Azure SQL DB, you've got Azure Data Warehouse, you've got analysis services, SQL Server, obviously. You can do on-premise too, obviously, integrating with a hybrid. You've got blob storage and Azure Data Lake storage. So you've got a lot of options, and all of those will integrate nicely into Databricks very easily. You also have Active Directory tight security and all its features of that, and that also integrates into Databricks. That was a key part of what they did in this integration. So you get the safety security of Azure Active Directory, authentication, point and click, ease of use, and use of all the resources in Azure. And then now I can talk about what is Databricks itself providing. So in this environment in which it allows collaborations and even role-based assignments, who can use clusters, who can create them, who can run jobs, etc., all that kind of control, you get these certain objects. So the first thing I'm talking about, easy cluster creation, is just point and click. How many nodes do you need, etc. There's security, obviously. And now we'll look at scheduling, notebooks, and collaboration. At the core of this is the notebooks. So the IDE in this, the development environment in Databricks, which is provided, because Databricks is sort of all-inclusive, batteries included kind of environment, they provide you with a notebook interface. So if you've used something like Jupyter Notebooks, same idea. They look more like Zeppelin notebooks, very similar to Zeppelin, I've noticed. And so it's where you develop things, and we'll see that. So that's really one of the parts of it. And when you're coding in your notebooks, and you can mix languages supported by Spark, which includes the language I talked to you earlier about, as well as SQL, you can mix and match those throughout a notebook, which is really nice. So whatever languages you're comfortable with, or maybe have a certain functionality you want to leverage, you can do that. All right, but where does R and Python, what is my topic got to do with all this? So what my topic has to do with is this idea that with R and Python, and for that matter Scala and even Java, there's a lot of written libraries out there that are open source and available for anybody who wants to use them. So a good example in the case of R would be something like ggplot2. And ggplot2 is a very powerful graphics engine that provides all kinds of functions and package that provides functions that allow all kinds of visualizations. It implements a full-featured language called the language of graphics to allow you to do all kinds of cool stuff in R. So if you want to use a third-party library that is not available, in R it's called a package, Python generally calls them modules, but if you want to use these libraries, you need to install them. Now in the case of Databricks, it does install a lot of them for you. So ggplot2 is already installed for you. You don't have to install that. A lot of common libraries you would use are. In fact, Python has a ton of libraries already installed, and the ones you would standardly use in machine learning and data wrangling are already there. So pandas is already pre-installed. Matplotlib, NumPy, scikit-learn, all these things are already there. So Python actually had so much trouble finding something that wasn't already installed for you that I'm just going to show you one that is installed. But there's so many Python modules out there, I'm sure you'll find something you may say, I want to use this, and you'll know at least the process for doing that. I'm not going to focus on Scala and Java because I think really the key thing I want to really touch on more is the R and Python as the key data science languages you're going to be using. And to kind of make my point a little bit, so if you go to the CRAN, Comprehensive R Archive Network website, you can go to all of the packages they have. I think last count it's over 10,000 packages available. These are open source, they're free. Some are very specialized, like genomics and things related to that. Some are visualization and data and all kinds of tools like that. So they're really powerful. I'm going to show you how to install and use one that is not available by default on Databricks called Psych, and we'll play with that a little bit. But you get a lot of functionality from this. R tends to be a little more limited in the places you have to go in terms of getting packages. Generally, CRAN has most of it, sometimes GitHub, and a couple other places, and you can get them. Python is a little more wide-ranging. You can get packages. Anaconda has a whole distribution that will give you a ton of machine learning packages out of the box, so they give it to you automatically. But the one that's supported directly by Databricks is called PyPy, which is kind of the standard place to go for a lot of those. And you can also install or load, if you have modules on your machine, you can bring them in. Python, you create eggs called Python eggs. I'm just going to focus on what's available in the repositories for this. But you can see here lots of different libraries available. And in Python, there's so many that you really have to kind of do a search and try to nail down what you're looking for. Because Python's an all-purpose language, whereas R is really focused on machine learning and data science. Python can be used for web app development, mobile apps. It could be used for anything you want to use it for, automation, operating system or admin automation of your system. It can be anything. So let me start in and I'll show you how to use this. Go here. And when I go into Azure, I would go to the portal typically in Azure and then just click in and drops me right into the Databricks workspace that I'm working in. Again, my other video talks about creating the Azure Databricks workspace. It's a few mouse clicks and you're there. And then after about 10 minutes or so, maybe a little longer, it creates the workspace. And then once it's there, you can just drop in by clicking on it. I pin it to my dashboard. But assuming we've gotten this far, I'm going to go to first check my clusters. So clusters are a collection, if you will, of machines under the covers. And each place that's going to do work is called, each basically container, if you will, it's going to do work is called a node. And so I have work to be done, and I'm going to kind of use an analogy I've used in the past. If you heard it, sorry we kind of beat on it, but I want to make sure it's clear what's happening. When I submit a job, let's say I have something like a phone book, and I want to find people who live on Main Street, and I want to do it quickly. One way to do it is have one person do all the work. That would be your standard server. Another way would be maybe split it up and let multiple people do the work. What if I took it and said, I'm going to give each person all the last names that start with a certain letter, since it's alphabetical already, phone book works well, A's go to John and B's go to Mary, and you kind of go through and you give everybody the work, and then you say, here's my instructions, and everybody gets a copy of the instructions, i.e. the program, and you say go. And obviously everybody does the work, and then they hand it back up, and somebody collects it all and says, okay, now I have the results from everybody, and then eventually that goes back to the program that requested it, and that's in this Spark context. So understanding that sort of framework and how it works, you can see that's obviously going to be a lot faster, because if I only have to go through like the A's, and I don't have to do all the other letters, I'm going to be done really quick, and same for everybody else. So we can get work done faster. And what if we split up even more finer than that, and finer, you know? We could split it up to 1,000 people or whatever, and then it's going to go really fast. And the beauty of it is, you would think maybe in economics you hit diseconomies of scale at some point. It doesn't quite scale. However, we don't hit that problem in this case. It scales linearly. So it's basically kind of a straight line. A very consistent additional amount of time, but it's manageable, and you can handle pretty much petabytes or almost infinite amounts of data, and it's able to scale without adding sort of a disproportionate amount of overhead. So that's a really cool thing about it. So when I create a cluster, I mentioned this earlier, I can set an automatic timeout, really important to save money, and I can set min and maximum workers. So those workers are really the executors under the covers, and that's going to determine how much resources I'm consuming. Nice thing here is it will dynamically scale based on the work I give it, and I can have it turn off when I'm done. So that's really key to managing my costs. And as a result, normally I would come in here and this would be stopped, but to save you guys time, and I didn't want to have to wait during my demo, I can come in here and I can just go and say start on the cluster and say confirm, and it will say, okay, I'm going to start that. But I did that already on this. A little thing too in Databricks, if you hover over things, a lot of times things appear. Like if I want to see the Spark UI, I can do that here. So just hover over things a lot, because you may not realize things are available. All right, so the first thing I want to do is go in here, and I need to bring in, I want to bring in a new package for R, we'll say. So I'm going to go in here. I'm going to go to my library demo here and see. I'll do it in this main area. So if I install a package, create a library in the main workspace, then it means it's available to everyone. If I do it in a sub workspace, like in a, say, somewhere here, users, I can go into myself and say I'm going to just create here a library just for me. Nobody else will get it. So let's do it in the main area. I'll say create, and I'm going to create a library. And I can do Java Scala, I can do Python Egg, I can do R. So let's start with R. And here I'm going to say, okay, I want to install the psych library. Okay. Now in this case it already exists, but I think I can do something, a little trick here. Psych2 does not exist, but I wanted to follow through here. But ignore this for a minute, because all I really want to show you is I can say here, attach the package to the cluster, and it will attach to that, and you'll see it's detached. It will attach itself. I've already attached this library, and so it's telling me you've already got that there. I can't reattach it. So it's probably not the best example. Let me try something here. Maybe I can do something a little different, just to kind of give you an idea of what I'm doing. So I'll go back here and I'll say, okay, create library, and I'll do R library, and here I'll say SQLDF. Okay, I can use that. So that is a package that's available, and that basically allows me to do SQL within R, and then I can say, okay, attach it, and then you'll see it saying I'm attaching, and that can take a little while sometimes for it to attach a library, depending how big the library is. It's actually going to go out, bring it in, install it on the cluster. Now while that's happening, I need to make a point. It's attached already, so that was quick. When I'm running, I'll show you in the notebook, but when I'm running it, it will not scale out with open source packages because they weren't written with any ability to do that. So for instance, SQLDF is written with no knowledge of how many CPUs you have, no ability to page memory in and out. I don't think, at least most packages do not, and certainly no knowledge to understand how to coordinate among multiple nodes or workers within a Spark cluster. When you really want to scale out, say, machine learning, you need to use something like Spark MLlib, which are smart and aware of the Spark environment, and so they can scale out and coordinate their work among multiple nodes. And so when you do things, and I'll sort of backtracking a little here to give some background, when you need that kind of Spark scalability, you need to run on the nodes. You need to use an API for your language that understands Spark and can implement what your work on Spark. So in the case of R, it would be Spark R or Sparkly R. In the case of Python, it would be PySpark. And then Scala has its own way of integrating, and Java integrates as well. So you're good to go on those. So that's the key thing. So Python actually has a somewhat more robust support for Spark, because PySpark actually supports machine learning models in many cases. So a lot of the MLlib exposed models PySpark can connect to. The Spark R is more limited in its ability to make use of machine learning in a scalable way. You can extract subsets, which is typically the way to get around that. So if you want to use say R machine learning on something, or you want to do visualizations with either Python or R, typically what you would do, say you're doing something like you want to do a linear chart or cross pairs, typically you would do is pull a subset out, do a sample, maybe 10%, 1%, something is reasonable, and then you can work on a local node and do the charting. And local node means it's just working on one machine as if you were sitting on just a client running. You're not going to get that scalability. Many times that will still deliver the kind of functionality you need, because if you've got a pretty good sample and you've got, say, a trillion rows, and you pull it down and say, well, I'll only pull out 50 million rows. If you sample it correctly, you should be able to get the same kind of analytical visualizations, etc. You get something pretty close. So anyway, that's my story on that. So now that we see it's attached, in this case, I'm not really going to use SQLDF. The one I attached earlier was actually the psych package. So let's go here. And in order to bring up I'm just going to go here to my recents, my library demo here. And so this is a package. And what I can do in a package is I have these cells, which you see these little magic commands. Those tell it what type of cell is this. So in a notebook, if you haven't used one, it's just a series of boxes they call cells. You put the code in the cell and then you run it, and then the output's immediately rendered directly below it if it's code. In the case of MD, it's Markdown. And these are intended to really just document, provide comments and annotations. So I'm saying here, using our open source library, blah, blah, blah. And these little markers here, these pound signs, equate to HTML. So 3 pounds means an H3 tag. So it's just a way to sort of format the text. And then if I do Shift Enter, or I can go over here and just run the cell. In this case, you can't run it because it's not really code. But what I can do is just say Shift Enter, and it runs it. And now what I'm going to do is run this, and %R is a magic command that tells it this cell is for our language, because the default for this notebook, when I created it, I said it's a Python notebook. So whatever the default language is, I don't actually have to use a magic command to tell it. It assumes, if I haven't told it otherwise, it's that language. So what I'm going to do here is I'm going to say, okay, it's R, that's the language. Library tells it to load a package into memory. So I'm going to bring in the psych package, and I'm going to use this cross pairs visualization. You can see it here. So what we've got is the iris data set, which is built into R, pre-delivered, and I'm just doing a correlation matrix, basically, showing each column and the correlation with the other columns. So I can see sepal width and sepal length have a 0.12 negative correlation. You can see the scatter chart doesn't show a lot. The strongest correlation obviously is between petal width and petal length. You can see that whole thing, but it's a good, so this would be something you might want to use. I probably would typically use in sort of a preliminary data analysis going into some sort of trying to create a predictive model. Now, Python, as I mentioned, has so many things installed already on Databricks for you that I couldn't find a really good use case of something I really needed to use, and so I decided instead just to assume we had not had, say, Seaborn or Matplotlib, and we had to install it. And assuming we had to do that, then it would be just like they were pre-installed. You would just import the libraries, as you see here, and then you could run something. So I can now run this here, and in this case, it just kind of does a scatter plot with a line going through it, and you get the idea. So again, you would install it in that case from Python. It would be from PyPy. You would just give it the name, just the way I did with R, and it will bring in the package you want, and you're good to go. You have to attach it to a cluster. So a key takeaway also is when I download the module package, whatever term you use for these, it stores it on the blob storage within Databricks. So part of what you get when you create your Databricks environment is some local blob storage for you to support your Databricks immediately. And I can store some data there, and I can do different things. The libraries and notebooks, etc., get stored on that. Because it's not on the cluster itself inherently, it means I can just bring them back. They're not going to go away when the cluster stops. there's no problem. When I have a new cluster, I need to add packages to a cluster. As you saw, I have to attach them to the cluster. So you have to make sure you attach them to the cluster and stuff like for that. So when I loaded it, I could do that. All right. So I think that covers just basically packages, libraries, when we use them. And the big takeaway, though, is when we do this, we probably want to make sure in a case like we're doing this that our data sets are small enough to be handled on a local node only, because it will not scale out a code by default. And I will be looking to do a future video to talk about HD Insight using machine learning servers specifically focused on R, because the R server component of that allows you to get better scalability to actually scale out a lot of your models over Spark, which is not something directly here available, but it is available there. So if your primary language is really R and you just want to do everything in R, that might be something to look at, because it does have that functionality. And R server also supports the idea of taking arbitrary R code and saying you want to distribute that code over the cluster so you can hit on multiple nodes. And again, that's a very powerful feature. So so I'll talk about that as a separate thing, but our server has some really nice functionality like that. Let me go back to here. All right, so we've talked about how to bring open source libraries for like R and Python, but applicable to Scala and Java, how to bring those in and make them available to our Databricks account at Workspace so that we can use them in our notebooks. And we covered a lot of things. We did a little background on Databricks. We talked about the scalability, and we learned that you can't take open source packages and just spread them over the cluster over all the workers. By default, it's going to run on the local node. And we talked about like kind of extracting and kind of getting subsets of data if you're going to be doing stuff like that and you want to work on the local node. Don't do it with a petabyte. It won't work. Hope you've liked this talk. Please share, subscribe, like, tell people, tell your friends. It's really good to get benefit. I always do this at the end of my videos, but get the word out there, because the more people that watch these, the more exciting it is to see people getting the benefit from it and gaining. And that's what it's about, is sharing, collaborating, and making things better. Thank you.